Yeah.
Appreciate you guys coming. Cool. Awesome. I know we have a few minutes before we are officially supposed to get started, but wanted to get a sense of who else here. I see the Synapticon folks right here. Curious about the context of the Novanta folks we talked to earlier. Everyone else, functional safety people or focus on awesome.
In-home robot deployment, so safety is critical.
Relevant.
Yeah.
Excellent.
Hopefully we're all safe.
Yeah.
Yes, a key piece of what we all do. Curious to hear about the rest of the folks. What context do you
Sure, I'm in the safety.
Excellent. Fantastic. Great. Cool. Maybe just the last couple of folks. Curious if you come from a functional safety background or just here out of curiosity? Excellent. Great. Perfect. And I guess a couple more people.
I work for an entertainment company, so
Awesome.
we're going to put robots around people.
Need to work with this. Great to hear.
Construction or residential construction.
Excellent. Cool. And then very last person in the back, but bigger. Functional safety background or just
functional safety
awesome.
background, yeah.
Cool.
Sorry, just an investor looking at this space.
Fantastic. So that's good. Exactly. As it goes. And then of course from Sergey Coop. If you guys didn't get a chance to speak to him, also related space, insurance, good stuff. Cool. Awesome. Well, thank you guys for having me. Thanks for coming to the talk. I'm Akshay, founder of a company up here in San Francisco called Saphira. We are focused on automating risk assessments and safety case development for robotic products. Have worked on industrial robots, ASRS systems, various aerospace products. And we're here mostly to learn from all of you. There's a lot of exciting work being shared tomorrow, especially on standards development. And I want to share a bit of the things that we are thinking about that hopefully open up collaborations with folks that are much farther ahead, much deeper experts in the space, like the Synapticon folks here and 3 Laws in the back. Lots of good stuff. Cool. Let's see. So one of the places that I wanted to start was just by saying this is meant to be a pretty open-ended conversation, so please interrupt me at any point. Want to make this as dynamic as possible. And the last thing I'll say is the focus of this talk is more on our practice of applying AI in the actual functional safety evaluation procedures versus in actual functional safety mechanisms. So that's definitely one distinction from, I know what a lot of folks here are working on, what a lot of the other people that come from machine learning backgrounds end up doing in the space. So hopefully that provides a complementary perspective to the kind of things that many of you are thinking about. Cool. Okay, so we'll start by, at a very high level, stating the obvious, which is that the safety challenge is the biggest adoption it's the biggest adoption blocker for humanoids. We have so much diversity of environments, and to be able to build safety cases, either you need to massively restrict your environments like we do in industrial settings, or you need to be able to take a completely different approach. And that's the hope of what we're expecting to see out of the standards bodies that are being represented here. People shifting to more of a performance metrics driven mechanism for evaluating safety. And that's kind of the bar that we want to bring to light to be able to build some of these new safety cases. Cool. One of the key things we'll make reference to a bunch throughout the conversation is the fact that there are really unique risks that all of you guys are familiar with when it comes to light falls and the number of points of failure and points of hazard, pinch hazards, crush hazards from all kinds of robots that exist that are being built here. And that's one of the biggest things that we are trying to make easier to consider when we develop our risk assessments. All right. Cool. I'm going to skip through everything I've stated here because there are real experts on the new standards being written that are going to share their insight tomorrow. We're really excited to learn that, but the biggest thing I expect they'll be speaking about is some of the work coming out of the WK86916 publication on disturbance reduction testing for legged robots. So the kind of stuff that you've probably seen a bunch of people evaluating here, kick tests, standardizing the amount of force that we want to apply, and creating a benchmark for how people want to evaluate this. The biggest thing that I want to make reference to, and the place that I find most exciting to think about, is what's going on with IC 62988. If you guys are working on, which I know many of you are, some of these different person detection mechanisms, the follow-up coming out of the section 3 that was published last year of this is, I think, going to be the most important thing that's going to come in the next couple years, hopefully. What we need is the ability to effectively take a step back from, again, the really tight constraints of deterministic detection and state what kind of risks are acceptable when it comes to misclassifying humans, especially in occluded scenarios. And that's one of the things that we're spending a lot of time trying to think about. And I don't have a ton to share here, but it's something I want to open up for conversation as an ask to people in the audience as we continue. So before I dive into actual examples, the couple last things I want to make reference to, I think are most exciting to think about recently, are the fact that we have the ability to create much more redundant sensor layouts. This has been, I know, a key thing that many folks in this room have been working on, including us in the back, where we have the ability to loop in non-safety rated sensors into safety rated functions. And that is going to be a huge precedent for how we're going to need to think about safety functions for humanoids. So when we think about the second half of what we do, of going from a risk assessment into the development of new control measures, this is something that we're now able to take advantage of, that we want to be able to ideate on maximally. And that is something that, we want to dig more into. Secondarily, one of the biggest things that we're able to see now is that new inference stacks actually allow us to have high-speed enough processing to produce complex decisions off of raw data in relative real time. One of the biggest things we learn when studying ISO 13849 is the fact that that we have really tight reaction times that are expected from certain sensing modalities, and the fact that we now have the ability to create those same reactions over short periods of time is critical for many of the safety functions we're going to pinch. The last thing that I want to set as a groundwork for a lot of what we're thinking about these days is the fact that wireless safety is becoming more of a point of conversation. There are actual production systems, AMRs, that are deployed with external sensors in heavy use. And this is the kind of thing that comes up in many of the conversations here as something we want to try to avoid for a lot of humanoid applications, but want to make sure that we consider the fact that that's something we can take advantage of. The fact that there may be other environmental sensing mechanisms that help reduce risk in the environments we're operating in, and that can create.
On the last item, are there networking things? So Wi-Fi is not creating handoffs and things like that. Are there good networking standards that people are using, or outside-in tracking, things like that, to communicate with AMRs and other mobile robots?
It's a very good question. I'm not so familiar with the non-safety side of this, but a lot of what we've been a lot of what we've been digging into has been there are EtherCAT implementations allow easy adoption of FSOE, and as long as you're using the right protocols on top of IP, you can use whatever underlying mechanisms you want, such as Wi-Fi. Now, the biggest problem is that many of those approaches haven't yet fully been certified, and so one of the big things that we've been working on with a couple of our clients has been taking a couple of these new approaches and actually starting the certification process for open networking standards that we could utilize here. So hopefully if this is something that you guys are getting more into, we'd love to have a conversation there and see if some of the things that we're planning to open source in the coming months may be valuable. Cool. Curious, just to toss it back, if there have been things that you've been watching out for or challenges you guys have been facing.
I mean, we're always, in our industry, we're always looking for lower latency, especially as it relates to safety applications.
Absolutely.
And a lot of the existing networking infrastructure, it's it doesn't work in big metal buildings, similar to a warehouse or a DC. That's kind of we work in similar kind of applications. So we're looking at other networking technologies, things like CDRS have limitations that we're looking for the frequency sharing. So I was just curious whether people stumble on something that works better.
Yeah, we should definitely talk about this afterwards. There have been a couple of investigations we've been having there. That we'd love to trade notes, but nothing that is robust enough to share in a presentation. Awesome. Okay, so the final point that I was going to make before I dive into a little bit of our action strategy is, we've tried to take the traditional functional safety approach and boil this down into a sequence of steps that we can actually build into an agentic or automated process. So obviously this is, when you see other framework compositions, this is not typically how we think about the functional safety approach, but we typically want to state that we start by assessing hazards as broadly as possible, looking for references to consistent approaches to mitigating those hazards, and then looking for places where those are potentially mitigated by the specific dynamics of the kind of robots that are being built here. So this is a point of conversation by many folks earlier, where if you are able to say that, hey, we're only operating in extremely with extremely light products in less hazardous environments, then even when you see particularly severe hazards, there may be an opportunity to say, hey, there are alternate ways that we can reduce the impact of that. And in the end, the objective of all of this is to try to look for ways that we can fall back to secondary control for what we're doing. And that's kind of the dream state that we can package up a lot of the way that we think about this into a consistent mechanism. So I just included from directly from 13049 some of the way that we think about breaking down hazard analysis into looking specifically at, and this is the mechanism that any functional safety engineer actually uses to evaluate their PLR, and this is how we want to automate the process of doing this. So I'm going to quickly share a video of how we have thought about doing this, and then refer to a little bit of what we've done. So I think there's audio that will come through, but it's not super important. I'll just talk through this. So this is a template UI that we put together where we're analyzing a particular single arm with no variation, and we want to try to systematically look for the sorts of hazards that will emerge with this arm. So the way that we typically tackle this is that we start by looking for particular tasks that we expect to emerge from this arm, and then generating off of that hazards that emerge from those particular tasks given that structure of the arm. So for example, we describe here classic hazards like unexpected startup, but the idea is one of the main things that CAD input allows us to do is look for specific sorts of hazards that only emerge with this kind of system, like your pinch hazards. And from there, we want to put together particular, we want to be able to put together a particular evaluation criteria. And that's where we start getting into this point of conversation around using examples that have been set out well in both the Type C standards and in existing precedents for how we should go about testing these things. We'll let this play out, but the main thing that I want to make reference to here that we've done to be able to enable this is we want to be able to encode all the information we have about a product in a semantically queryable format. So one of the biggest things that we invest in is taking both standards and product definitions themselves and turning them into knowledge graphs, and building up this way of determining relationships between particular items within your system and actions that they might take, and finding those sequence of relationships whenever we're evaluating how to approach a particular test or how to approach a particular control measure. So this is one of the biggest things that we think is a huge opportunity for how people will continue to build up new types of safety cases, and a big piece of what we're trying to focus on building. One of the biggest things that I want to make reference to in terms of how this can actually be utilized is we've actually started to see some interesting things happen deeper down the industrial control stack, where there are finally drives and other components that are being certified entirely in simulation. And the biggest way that people are able to do this is by ensuring that they actually capture the actual stresses that will occur in the wild in a sufficiently realistic way. And so one of the hopes that we have in, from the very high level that we showed, breaking down from our initial statements of very high level hazards into particular metrics that are being measured, is that we can start defining what you'd actually need to capture in your digital twins to be able to do this for all kinds of other systems. And so the hope is that this is kind of the core outcome from the kind of work that we're working on enabling, and that ideally others are working on here. That kind of captures a lot of the bulk of what I wanted to cover today. There were a couple last things that I've written about around effectively leveraging existing standards and thinking about how to develop the metrics that you want to actually utilize. I think I've covered most of what I wanted to cover here, and a little bit of what we've seen folks do in the real world. As we talked about earlier, there's a little bit less happening, a little bit less presence here at this conference from the biggest players that have likely seen exactly how this plays out. But one of the biggest things that we're trying to do as an organization is gather some of the information, what they're actually doing, and publish that. So hopefully some of that will be coming out soon. I think the point that we discussed earlier is one of the biggest things that I wanted to mention here as a key area of work that we're focusing on. Which is taking some of these new communication protocols that are emerging and standardizing them for broader use. And so that, as well as some of the rest of the challenges you guys are thinking about in terms of defining narrower metrics for compliance of use of AI and safety functions, really the biggest things that are coming. That's about it. We are here excited to collaborate with people, thinking about different parts of this problem. So if you're interested in talking further, I have my email here. Definitely give me a call. Awesome. Thanks, guys. Any questions or things we can answer?
Where do you see like the overlap between functional safety and the operational safety? It's been kind of mentioned as two different worlds, which I think is a problem, right? How do they come together? Who's making sure they come together?
Yeah. That's a good question, and something that I think most of where I think about that is in terms of defining these hierarchies of metrics that you're measuring, saying that hey, we if we're able to measure operational safety at a particular level, then we can break that down to those same observations of individual functions within your system, and really most of what you care about is the traceability that you end up finding from that. So I don't have any particular answer to that point, but I think our approach is you want to measure as much as you can, and you can back your way through trying to build up that story.
Yeah.
So,
I have a question. I have a background in computer science, and when you think about safety, it's usually like the master-slave principle. So if you have a robot, for example, that operates based on what you designed it for, and the safety can either be built in, or it can be a separate system that would check the safety of the operation of the robot, meaning independent. So what approach are you evaluating?
yeah, It's a very good question.
Can you comment on that?
Yeah, I think the hope on our side is that you should be able to evaluate both of these in a very similar way, and that's part of our pitch in saying that, hey, you should use a standardized mechanism for performing risk assessments regardless, because if you develop a safety function that's external that produces the same outcome at all the levels you need, you should be able to reference that in the build case for your internal system, or vice versa. So I think the hope is that a lot of what we've relied on external safety mechanisms for historical industrial systems, we can now build onto a single bot with humanoids. But obviously that's not fully possible at this point, and so we want to understand how close that feature we can actually get. I don't know if that really answered your question.
So in the absence of like standards you can go through, and in the absence of a lot of operational data, because a lot of these humanoid companies are early on,
Yes.
like what do you think is the best thing they can do in terms of like generating evidence to convince their customers that hey, this is safe to use? What would you recommend?
Yeah, I mean, from my perspective, the two most important pieces of this story are indicating to your customer that you've evaluated as many edge cases as possible, hence the fact that you want to produce as broad of a risk assessment as possible, consider a wide range of hazards, and then limit in whatever ways you can the environment that you're referring to when you build that particular hazard analysis. And from there, ideally, you want to produce two types of evidence. So one type of evidence is, again, in your internal tests, having produce as many of those edge cases as possible, and focus on the span of testing versus the sheer amount of testing you traditionally focus on. And then secondarily, show that you've been able to simulate as many of those as possible reliably. So actually demonstrate the failures and demonstrate basically the version of that. And yeah, our hope is that as you're able to demonstrate a broader swath of those, indicating that you have started from the top of reducing the most severe outcomes and ensuring that no matter how rare a particular situation is, you've considered it, then that starts to build the safety case that's viable to these customers. And that seems to follow what a lot of the new industrial robotics ecosystem kind of backed into with AMRs, where you started by saying, hey, well, we can kind of simplify what we look at and focus on mostly the high-risk scenarios. Just really evaluate those.
And quick follow-up on that. Do you think the emergence of standards is going to make the process easier for these companies to go through, or more difficult? Because I can see some ways it makes it easier, it adds structure, but it can also add requirements that might be hard for these companies to achieve. So I'm curious your perspective on that.
Yeah, I think we usually talk about this from the angle of the hope is that new standards follow the principles that are being set out for automotive and aerospace, where ideally they back away from setting extremely strict requirements and back towards setting somewhat more performance-driven requirements that align with the kind of testing that these teams are doing anyways. So our hope is that by continuing proliferating the thought of baking safety into your core development process, it becomes much easier for this next generation of companies to go through that final certification process. But of course, that relies on having alignment with all the different companies. The hope is to make it easier. Cool. Thank you guys for listening.
Thank you so much.